Hello community! Today we talk about synthetic science with AI, and I have one question only. Is it possible today with AI to write your PhD thesis in one day and one day only? So, unfortunately the answer to this is yes. And if you want, I show you how to do it. So let's start. We need to find our tool for our toolkit, therefore we go here to OpenAI, August 13, 4 days ago. We were told that OpenAI introduced a new benchmark, SWE Bench Verified. And you might say, hey, why? Well, OpenAI tells us the best coding agents on this planet, the best coding LLMs that are available on this planet for money, have made an impressive progress on the software engineering benchmark, with the top scoring agent on this planet already scoring 20% of the benchmark data as of August 5th, 2024. And you might say, amazing! So we have a 20% performance and only in 80% of the cases it is doing something completely wrong. So therefore, they decided to come up with their own benchmark, and they call it now SWE Bench Verified. Now, OpenAI worked with the original creator of SWE Benchmark, and they have here a human annotation process, and today, 4 days ago, they were releasing here SWE Bench Verified, a subset of the original SWE Bench, the very hard to solve one, to the world, consisting now of 500 samples verified to be non-problematic by our human annotators. So an AI company is releasing a non-problematic subset for software engineering. And you might have a feeling how this goes. And yeah, you are amazed because GPT-4 Omni now resolves 33% of all the samples of this new SWE Bench Verified with the best performance open source. You remember GPT-4, you have to pay a little bit for this. With the best performance open source, agentless, doubling its performance. Now you might say, hey, I know agentless. Yes, of course you know it. Because if you go here and you put in agentless into search on my channel, you get immediately a new agentless AI software development of 1 month ago. And of course, we have this now on the official SWE benchmark page. So here we go, and you remember this is here from Princeton, and University of Chicago. And here we go, and if you look now, we have here the verified benchmark and the leaderboard. And you see, we have now on the silver medal goes to GPT-4 Omni. Interestingly, the one from May, not even 0808, but the old one. And now we achieve not 33%, but 38%. Isn't this impressive? So on a dedicated subset selected by the AI company who provides AI machines to solve this, now we are at 38%. Well, of course, if you go for the full-fledged SWE benchmark, you see all models, even the gold medal here, are below 20% success. But you see here with AutoCode Rover and GPT-4 from May, we achieve 18%, which is great. Because if you compare this to the best RAG application here with Claude Opus, you see we have 3%. May I repeat this? 3% with RAG. The best SWE agent with Claude 3.5 Sonnet, that also I use, is at 18%. And now the latest is at 18.8%, and there's even one with 19. So best systems on this planet are below 20% for the full software engineering benchmark. If you want to learn more about this, and especially here about the AutoCode Rover implementation for GPT-4 Omni, this is the GitHub repo for you. Autonomous program improvement, and they tell you, hey, August 14th, so just 1 day after OpenAI published this, they say, hey, on our SWE Bench Verified benchmark released by OpenAI, achieves 38.4 efficiency, and isn't this great? So this, if you want really to be here in the top spot for the verified, for the silver medal AutoCode Rover plus GPT-4 Omni, and maybe you're even better if you go with the August release of GPT-4 Omni. Great. Let's go to the next one. Yeah, for my green grasshoppers, if you want to read about the software engineering benchmark here by Princeton University and Princeton Language and Intelligence and the University of Chicago, this is the paper for you, April 5th, 2024. Now, the next tool in our toolset that we need to write your PhD thesis in one day is simple. It's Ada. Now, Ada is beautiful application, is AI pair programming in your terminal. And Ada lets you pair programs with LLMs to edit code in your local GitHub repo. Isn't that beautiful? You just need your own GitHub repo where you have all your code, and then you take an LLM, let's say you go with Claude 3.5 Sonnet or GPT-4 Omni, and then you start a new project and Ada will do all the code for you. To tell you, Ada works best with GPT-4 Omni and Claude 3.5 Sonnet and can connect to almost any LLM. And you have a detailed explanation how to get started, all the features, all the things it can do, edit your files to complete your request, automatically git commits changes with a sensible commit message, works with the most popular languages, Python, JavaScript, TypeScript, and more, can edit multiple files at once for complex requests. And this is great. I especially recommend here the Ada blog. About every month you get some really interesting insight how the systems are doing and how the performance are doing. So maybe you would like to have a look at Ada. We need it. So this is here a GitHub repo by, I hope I pronounce it correctly, Paul Gauthier. And if we go down, they give you here all the code on everything that you need to understand and use Ada, and we will use Ada here. Now, we have also here from Paul Gauthier a beautiful explanation. What is this Ada agent? Because this is kind of a backbone that we're going to use for our software engineering. And you know, today almost everything is virtual. We can have simulation of mechanical system, of real-world system, and it is more or less a software optimization problem to do research at. Even if you build some hardware configuration, some hardware systems at first, you simulated it's working in a software environment, and therefore Ada agent, this will be our agent today, and it is, as the author tells us, it is that simple. It simply evokes Ada on a fresh copy of the problem's Git repo over and over again, iterating through the models it has been told to use. So this is your code for your computer simulation that you have in your GitHub repo, and there are problems. Maybe hyperparameters not working, or you get some error messages back, or so whatever you have, we will use Ada and an LLM, let's say 3.5 Sonnet, to solve the code problems and create new code. So Ada is invoked repeatedly until Ada reports that it successfully edited the code repo without any outstanding edit, lint, or test errors. This is a plausible solution, so the agent is done. Configured with a test command to run all the pre-existing tests in the repo. And if you look here at the pseudocode, you see this is a rather simple system, absolutely. You just choose here either GPT-4 Omni or your Opus, then how many attempts you want to have, and then you just let the model run, connect your GPT-4 or Sonnet or whatever, and it will do here all the beautiful interface work for you. How to install it, benchmark, everything is here. So here we have it now. This is our AI toolset. And you know what? Today in the morning, but just minutes before recording this video here on this weekend, I got an email by Harvard, and they have the new Harvard Business Review out. Now you know this is behind a paywall. You have to pay for this. So I can show you only the title. But imagine this. So in the magazine Harvard Business Review from September, October 2024, they are now telling you, hey, embracing generative AI at work. I mean, this is now business work and not just some simple coding. Now, if you read this article, and I can't show you, sorry, but you find ways, I'm sure about this, There is now an interesting insight, but unfortunately it's not by Harvard, but it is by, let me be precise, the Accenture, the Chief Technology Officer of Accenture and the Global Managing Director of Tech Research at Accenture, and they tell you also about an AI scientist. That they refer here to an AI scientist, but you know what? They refer you to this paper here from the beginning of March 2024, MIT, Training Sorts and LLM to Learn DNA Structural Biophysics. And they talk here about an AI scientist, a tool that is capable of integrating a variety of experimental data and generating testable hypotheses. So Accenture, who just by pure accidents wants to sell you, the business, here their AI system and train your staff and you on their AI system, Accenture sees here the next years as the golden years in the AI consulting, and they give you here this information in their publication for September, October. And you might say, okay, but is this YouTube channel, is it better? Yes, because I will show you that we, you and I, we will have insights in a minute where we jump half a year in the future compared to what Accenture knows and what Accenture publishes, because today I'm going to show you this. This is a new publication by Sakana AI, and we also talk about an AI scientist, but we talk about the scientific stuff and how to code it and how you can use this, theoretically, how to write your PhD thesis and your 5 or 7 international research publication that you need within one day. And it is done, and you're not going to believe it, by an AI scientist, but a much more advanced, technologically advanced scientist than what Accenture refers to in its publication on Harvard Business Review. So, if you're interested, give this channel a like, and on we go. Now, you might say, okay, what is it all about? Now, to tell you the truth, it is simple, but don't tell anybody. So let's go there and let's have a look how it works. We need at first, if we do want to write a PhD thesis or a publication, we need a topic, no? So we say, okay, hey, listen, LLM, and we use, I don't know, GPT-4 Omni. I tell him in the system prompt, hey, you are an ambitious AI PhD student who is looking to publish a brand new research paper that will contribute outstandingly to your field of research. And then we have an idea generation prompt. So we have here a Python file, and please remember the name, experiment Python, because this is important for our template we're going to build later on. And in this template, in this experiment Python file, we have to have some content information. So at first, I say, hey, here are the ideas that I have already generated. So I tell GPT-4, look, these are my publication, or these are my ideas. This is what I'm working on. This is how I write publication, how I did my master thesis, or whatever you have. So you give here your personal type of writing, your personal focus on scientific publication. So the system understands how you write, on what topic you write. So I'm trying this out. I found this helpful if you provide additional information. But then you say, and this is the important part, you say, hey, GPT-4, come up with the next impactful and creative ideas for research experiments and direction you can feasibly investigate with the code provided. So I have my GitHub repo with, let's say, I focus here on transformers, AI transformer, AI architecture for grokking. And I say, note that we will not have access to any additional resources or dataset. So this is really the code I give you, and you have to play with this code. And I say, GPT-4, make sure any idea is not overfitting here the specific training dataset and the model and the end. And I say, hey, you respond to me in a specific format. I want that you have a sort where you formulate the sort, and then we have new ideas in a JSON format. And I give him the instruction, hey, in sort, first briefly discuss your intuition and motivation for the idea. This is for GPT-4 that was trained on human ideas and on human intuition. So we have to address GPT-4 like a human because it is just simulating identical pattern. And I say, detail your high-level plan, the necessary design choices, and the idea outcomes of the experiment. Justify how the idea is different from existing ones. So to do this, we have to give GPT-4 Omni access now to an AI database, let's say a Scholar from Google or any archive, any whatever you have, a database with 10,000 publications on your topic, because it has to check against the current state of knowledge. And in JSON, I tell GPT-4, provide the new idea in a JSON format with the following fields. You notice, simple. I say, what is the name, the descriptor of the idea, give it a title so it's identifiable. Now outline here the experiment here in the implementation details. Then I say, okay, give it a rating. Is it interesting, yes or no, lowest or highest? And you know now why we have access to some database of publication to have a check against something. You can have a feasibility rating. You can have a novelty rating, because if you want to publish something, it should be new. And then I say, hey, be cautious and realistic. JSON will be automatically passed. Yes, yes, yes. And you should stay within the format definition. And then we say, hey, again, ambitious PhD student looking to publish the paper. You notice by now you have an idea and you want to check if it's novel or not. So if it's overlapping significantly with an already published literature, or if you really have a new idea. So I say, hey, GPT-4, now be a harsh critic here for novelty, ensure there is a sufficient contribution in the idea for a new workshop paper, conference paper, international publication, whatever you have. And I tell him, hey, you will be given access here for example, Semantic Scholar API, which you may use to survey the literature and find relevant paper in the service to help you make your decision. And let's go for the top 10 results that you find. And those will be presented to you with the abstract. So this means you will be given a number of rounds, 5 or 10, to decide on the paper, but you don't need to use all the paper. Decide a paper idea is not novel. You will have found a paper that significant overlaps with your idea. So you see how it comes up here with the novelty benchmark. Decide a paper idea is novel if it, after sufficient research, you have not found a paper that significant overlaps with your idea. So you get here now, if you want, a benchmark in novelty, in feasibility, and in interestingness. Beautiful. Great. Now, I'd like to show you the novelty prompt. So in the round now you have this idea, and this is the idea. The result of the last query are respond in the following format, the sort, and then also the response in JSON. And I will gonna show you this because it's now a little bit boring. And then comes now the beautiful idea where we say, let's design now the experiment. Now we have Aider as our software engineering, and we have now an idea with a high rating. And now we say to Aider, hey, your goal is now to implement on my GitHub repo where I have the base code implementation, is to implement the following idea and give you the title. And your proposed experiment that GPT-4 detailed is now step 1, step 2, you know this. And I tell the system Aider, you are given a total of up to, let's say, 5 runs to complete the necessary experiment. You run here in this coding environment the PyTorch file 5 times. But you don't need to use it if you find immediately a solution. So first, plan a list of experiments that you would like to run. We're talking now to Aider, which has GPT-4 in its context. So we're saying you're sweeping over a specific hyperparameter, you plan each value you would like to test for each run, you define the interval from, 1.4 to 1.95 with a spread of whatever you can imagine. Beautiful. Note that you already provide a vanilla base result, so you do not need to rerun the basic code that I have here in my GitHub. And I tell you, hey, for a reference, where you start, the baseline results are as follows. So it has a clear benchmark to orientate itself, and it knows exactly it cannot go wild If I have a parameter, I don't know, 1.1, it cannot start with 10 millions, but it will go to 1.2. And after you complete here each run, you will run the command Python experiment. Now you know why I told you, hey, we have to design this experiment Python file really carefully. And then we tell it, hey, your proposed change must use this command format, no other formats, and then you can implement the next thing on your list. If we have not a result of those run, we just want to have a visualization. And you're not going to believe it. We told Ada here, hey, great job. Please modify plot point Python to generate the most relevant plot for the final write-up. So we give it here in my GitHub repo. I presented here from my other publications, my, I don't know, matplotlib structures where I show how and why I show specific hyperparameters, how they change over time, how they change over, I don't know, temperature and whatever. So there has to be some bone on the meat that the system can work on this. And after we have created here, we have the results of the test, of the computer simulation. Then we have here a visualization. We have some graph with matplotlib or whatever you prefer generated. Now it is time to ask GPT-4 to bring all together and write a paper. Because we know that GPT-4 Omni only has a 19% success rate, we have to provide some help. So we tell it, hey, look, I have given you here a template file in LaTeX where I showed you how I wrote my other publication, or you, if you start, you go anywhere and you take any LaTeX file of any publication that you like that is in your field that has chapter 1, introduction, chapter 2, what is the problem, chapter 3, I don't know where they can see, every 3 lines we have to have a reference, every 5 lines, or I don't know, every page we have 2 visualizations. You choose what you like and you have a template file here for the LaTeX. And then you just, hey, okay, now fill in this LaTeX template with our data, with our graphs, and write, quotation mark, the new PhD thesis or the new publication in AI for us. And after the system has done so, we ask now, hey, GPT-4 or whatever you have, now your role is the role of a reviewer. So you are a researcher reviewing now the paper that you just created, and you want that AI is now a critique AI, and that it looks very carefully, hey, is there a misinterpretation? Is there an hallucination? What is happening? And I would recommend that you don't do this one time, but I found in my experiment, I run this 3 times with different systems to really be sure there's no hallucination or there's no logical inconsistency. And yeah, we'll show you later. Maybe you integrate here a little bit here of a neurological, a little bit of here of a graph structure to help the system in the causal reasoning. But yeah, this is for the next video. So, and then we have here, so you evaluate the paper GPT-4, paper review prompt. Here's not a review form that I give here. And I say below is a description of the question you will be asked on the review form for each paper. Like any human reviewer, you get a catalog of questions you have to say yes, no, maybe, 1.4 or whatever. So here we have the review form for GPT-4, and this is it. Has to be filled out. Beautiful. You can define this for your evaluation. You know, if you work, I don't know, in biomedicine, you know the questions that are current question. You know the questions that are hot. So maybe in your training template, you formulate all those hot template questions that GPT-4 should answer now on this AI-generated research paper, so that you really have the hard question asked, and if your paper is really contributing to research or biomedicine or finance or economic research or whatever you are. And then you have a paper review reflection. Yes, we go really end to end. We have the complete pipeline. It's not just an auto ML. No, this is really something end to end. So in your thoughts, carefully consider the accuracy and the soundness of the review you just created. So you review the review, include any factors you think are important, ensure that the review is clear and concise and the JSON is in the correct format. Do not make things overcomplicated. And I will show you, we will look at those 2-3 papers that AI created. And I put this paper, I'll show you a little bit later, in AI detectors. And it was not able to detect that it was an AI-generated science paper. So yeah, you have the review reflection prompt, beautiful. And then you have the paper review ensembling system prompt. And they say, hey, now you're an AI or an area chair at machine learning conference. You are now in charge of meta reviewing a paper that was reviewed by, 5, 10, 3 reviewer. And your job is now to aggregate the reviews into a single meta review. So you simulate here within GPT-4 or whatever you choose here the complete process if you present this at an international conference. And you say, hey, GPT-4, you have access to all the research publication, the last 1,000 publication of this week or month in my area, evaluated against those 1,000 paper. And GPT-4 can do this simply. And you don't have to do this. And this happens in about 15 minutes, depending on your computer infrastructure. And then you get a review and you can simulate everything. And this is it. Yeah, and you can have some specific guidelines that you want to integrate so you know exactly against what here it is benchmarked. And yes, you get the idea, no? Now let's have a look here at the hyperparameters, at the specific implementation here from the universities. Idea generation, the number of idea reflection was 3, the number of novelty search round semantic scholar was 10. Experiment execution, the number of experiment was 5, and then you had a timeout of 7,200 seconds. The number of citation round was 20, the number of error correction round was 5. So you really go round and round and you have self-correction and self-reflection and self-whatever. So you use this to really improve, and I'm gonna show you this here. Number of reflection from the reviewer. So in each process step, you generate the idea. You go multiple times. You do the experiment. You execute the experiment. You go multiple times. 7,200 seconds. If you have a complex topic, might not be enough, but this is how much money you want to invest. Paper writing. Number of citation round. Go round and round. Review. My goodness, a lot can go here into the optimal review process that you learn, and maybe you start again after this review process where you get some critical information with the new idea generation to really make it outstanding. So you see what's happening. But now let me give you an idea before we do the programming. Let's have a look here. So what is the first idea that, let's say I do it, that I have? And I'm working here with AI and transform architecture, and I'm interested in grokking, you know? If you go there to my channel and you put here in the search grokking, you see we have here grokking LLM, structured grokking, grokking LLM versus RAG, grok drag. So I have a lot of videos on grokking. Beautiful. And now if I have this, I have the title, I have here the experiment. I tell, for example, what I have in my GitHub repo. Modify the experiment to dynamically adjust the batch size during training. Start with a small batch size and gradually increase this parameter. This could potentially lead to a faster generalization on the validation data set. And I have here specific parameters. You choose the parameters that you like, that are feasible for your research area. But of course, you should have this novelty, that it's really something new and interesting. Is it really in your research topic? Is this a hot question? And the novelty parameter, of course, is important. And then you just let the system run, generate ideas. So, but this selection of this first idea, this is crucial that you get the equilibrium right, because in your GitHub repo, you have the code for the transformer and the grokking phase. So you have to really make sure that whatever you address here, every parameter, hyperparameter that you address here, that is at least in the description here in your Python file, or it has a clear name here as a parameter in your file, so that you make sure there's a one-to-one relevance and you can't say, hey, do something that is not even mentioned in your Python file, because then Ada or GPT-4 will be creative and it will create some code, but with outside of some guidelines, and this can go crazy real fast. If an AI code is overwritten by another AI code that was evaluated by another AI machine, so you are in for a surprise. So let's see what happened. This is here seed idea, and now AI starts to generate 50 ideas. And you hope that every idea step, it gets a little bit better, a little bit more interesting. And they have given us here their 185 publication. The first idea. Investigate the impact of the model size on the grokking phenomena. This is clear, no? GPT-4 writes, modify the transformer class to accept variable numbers of layers and dimension sizes. Test the model with 1, 2, 4, 8 layers and a dimension size of 64, 512. So for each dataset and model size, track the step at which the grokking occurs, defined here as the validation accuracy exceeding 99%. So, clear, you have in your GitHub repo all the code. Over there in the code, you have the parameter, the number of layer is, and the dimension size is. And now, this is simply now done by Ada and GPT-4 here in this software engineering. Now they start to play with this parameter, or with the hyperparameter, or with whatever. And then you can say, just show you here, what if you compare this in a later step then to the Scholar database, to all the publications that are already published, is this something new? Is this idea valuable to the community? Is it novel? Is it doable? And on. So we run through the ideas, and you see here, if you want to go there, you have each and every idea. So let's go there to 25. The neural collapse in grokking. Investigate the feature geometry during algorithmic learning. And this is nice, no? Modify transformer to output the final layer features. Implement function to compute the class means and the covariance. Calculate simplified neural collapse matrix. The average cosine similarity between the class means and a ratio of within class to between class variances. Track the metric every 500 steps during the training. Run experience here on modular arithmetic and permutation dataset. Plot the neural collapse matrix alongside the grokking curve. Analyze the changing in the matrix before, during, and after grokking happens. Compare neural collapse dynamics between operation. And you get the idea. So the system gets better and better. The system learns here from the Scholar publications. It sees what is possible. It sees what it's already been learned. And based on this, GPT-4 then tries to come up with the idea 27. And you let it run 50 times. Beautiful. I just want to be clear that I show you here the final result. But you don't have to go with number 50. You can go with whatever you like. So, grokking for getting complexity, the interplay of task complexity and sudden generalization in algorithmic learning. So this is nice. So when grokking happens, does also forget happen before, after, during, to what extent? So give you here step by step. And step 1, multiple complexity level in your dataset. Update the training loop to gradually introduce higher complexity level while continuously evaluating on all levels. Implement a multi-complexity evaluation function that is not there in my code, but this will be created by GPT-4 or Sonnet or whatever your system you use that has been trained on all the GitHub libraries in the world to assess the performance across all complexity levels simultaneously. Track the metric, analyze the correlation between grokking events and performance changes and other complexity levels. You see, GPT-4 is, or whatever you have, is able to do this for us. We just need here a coding environment that is on your GitHub, Python, it's mine, PyTorch, or you can go with TensorFlow, you go with JAX, or whatever you choose. And with Ada, this system runs, if you want, autonomously, and the ideas are generated by GPT-4 Omni or whatever you like. And you see, interesting, 9, feasibility, 9, novelty, 9, everything is novel, beautiful rating. So maybe let's go with this idea. Okay, this was it with grogging, but let me show you the price. Because I found this interesting. If you do this, and we are focusing now on grogging, because they did this also in their paper. Have a look at the different prices. Let's say 50 ideas or 51 ideas are generated, novel ideas you see here. Experiments passed that were really successful in the execution of the automated code here. And then how many papers could be written that were really passing here? It's internal GPT-4 or Sonnet evaluation or Grok 2 or whatever you have. The mean score and the max score and the cost. So Sonnet goes with $250. And you have 25 completed papers with a mean quality score of 3.4. If you go with GPT-4 Omni, you're about $300. Remember, this is the old one from May. You have 13 papers, but the mean score is 2.92. So depending if you focus more on the coding, I personally, this is just a personal recommendation, don't follow it. I found Sonnet to be helpful if the code is complex. If the idea finding process is real complex and I need a little bit of in-context learning to provide GPT-4 with my examples, I go with GPT-4 Omni for logical complexity. But Sonnet 3.5 currently is real nice for code complexity. Yeah, if you go with DeepSeek Coder 1, it's unfortunately the old model, you just pay $10. And if you go with Llama 3.5, 405 billion, so the biggest Llama 3.1, you go with $120 and you have 30 completed papers, but your quality score is the lowest of all of those. So it gives you a feeling, and I have to say, I just played some days with it, but yeah, I would say this is about right. Also for my topic here in physics and AI. So let's do this. I would like to show, of course, you have everything on GitHub and AI Scientist. I'm going to show you this and the example of the papers. We go now for the grokking. And now, before we do this, I'm going to show you this a little bit later in detail. I just want to give you here a very simple demonstration. So let's go here from the official AI Scientist with the prompt here. JSON format, so we have the system. As I showed you, you're an ambitious AI PhD student who is looking to publish a paper that will contribute outstandingly in your field, and you will be the new hero in AI. Task description, and I just copy this. Beautiful. Now, you know what we do? We say copy. And I go here and I just copy this here to LMSys Chatbot Arena, whatever. And I just put it in and it is anonymously. I don't know what is model A, I don't know what is model B. Just put this in here and as you can see, task description. You're given the following file to work with. The abstract is, in this paper we propose to study the generalization of neural networks on small algorithmically generated data set. Question about data efficiency, memorization, general. Analyze here the process of grogging in the data. So this is my original idea. And now we say, okay, please come up with interesting experiments to investigate this phenomenon. And now those systems have not access to my GitHub repo. I just want to show you what they are able to do just out of the blue. Just given the task description, some lines, have a look at this. And I was really impressed. And we have here by Elon Musk, Grok 2 has nothing to do with grokking and Grok 2. This is just a coincidence in the naming, please. Grokking has nothing to do with Elon Musk. Grokking happens on GPT-4, on Claude, wherever. But Grok 2 is a rather new model currently. You see, this is the version here from the 13th of August, Grok 2. And we go here with a Llama 3.17 TB instruct. You decide what you like, but just to show you, experiment 1, grokking versus memorization. The objective, the methodology, and they give you here exactly train a transformer, gradually increase the data size, monitor the model's performance on the training set, on a separate training set, analyze the model behavior by computing the following metrics. This is done in my code. Memorization rate, grokking rate, hypothesis, as the data size increases, This is what you're going to check. Or experiment 2, grokking and overfitting. Investigate the relationship between grokking and overfitting. So Llama 3.1 70B with no additional data at all, no access to the internet, nothing, just giving you this, comes up with experiments. So here, the quality of your LLM that you're going to use, or vision language model, or whatever you have, is so important. And I have a GPT-4 system that I trained on more than 10,000 publications. And I tell you, if I run the normal GPT-4 and my hyper-tuned GPT-4 only on my narrow domain, there's a significant difference in the quality, of course, because it knows my domain. And this, of course, has no idea who I am or what I'm doing here. So optimize your LLM and you will get better experiments description. Experiment 4, grokking and the regularization techniques. This is interesting. This is really interesting. And I don't know if a paper exists. But you know what? Here, my ADA agent does the checking with the current literature for me, analyzes here how to write code with GPT-4, implements it on my GitHub repo, gets the results, uses here the ADA agent to activate my matplotlib library, prints out some visualization, and then uses here the LaTeX template to write here a scientific report that I can publish. My goodness, isn't this beautiful? Yeah, it has only one problem. It does hallucinate. Everything hallucinates. So you have to have control loops to take care about this. But theoretically, it really works. Unbelievable. So you have this here from Llama, and you have here by Grok 2. I don't know what you like, but you see you have more or less, let's look at Grok 2, complexity and grokking. Gradually increase the complexity of the mathematical operations from simple addition to modular arithmetic to polynomial equations to symbolic integration. Explore at what complexity level grokking becomes evident and how the transition from not grokking to grokking occurs. Unfortunately, it does not give me here the parameter and the threshold value that I would need for an even better code implementation. No, GPT-4 code implementation. So the more precise you get this here, the simpler it is for GPT-4 to write the code or for a Sonnet to write the code. So you see the interdependencies of the system that you use. You have to be a little bit helpful, and you as a human, you have to understand what threshold should be here in this verbal description. But you see, every LLM is able to do this. Beautiful. Now, there are a lot of other files if we go to the AI Scientist, and if you look here at the notes, you see here what happened in the process, and you can do here reverse engineering. You have here the plot program here in Python. We just looked at the prompt. You have here the review, the auto review here. So the AI generated paper with this title. AI is now itself evaluating. Says what are the strengths, what are the weaknesses, what is the originality. Oh, this doesn't look good. Then open questions. What could a reviewer ask about? What are the limitations? Ethical consideration, decision rejected. So this is not a paper that passes here the AI internal evaluation process. But now let's look here, I don't know, at the seed ideas. As you can see here for the batch size grokking, this was the original seed idea. And then I can show you what came out here a little bit later. If we now look at the code that we have to provide as a template to the system that it can do this. Ada can only operate here on our code base. So what we need? We need the experiment file, Python file. This is a single file. Well, the meat of the content is we build it now ourselves. But this is here, if you want here, a guidance how to do it. And now we do it ourselves. So let's start. Here with the meat of our content, this is here, in my case here, the code to build the transformer, run the transformer network, have here all the hyperparameter, all the tuning parameters, everything available. plot. This is here how I plot my scientific visualizations that I would later to publish in my report. Prompt, you notice, this is here the information about my template. The seed ideas, you put examples idea here. So this is my old publication, or if I have some 2 or 3 ideas that I would like that AI or GPT-4 is exploring, I say, hey, those are my ideas. Start with those. And then if you have already published or you found your publication that you like with the structure, with the amount of references, with whatever, you use here in a LaTeX folder here, you use here a template. So you see, so short recommendation, you should use here in your LaTeX file here some publications that are written by a human. So you have all this human special notation and everything. So do not choose here an AI written publication, but find a publication you like. Take here the LaTeX template, or take here the LaTeX template here as published here by Sakana AI, just to start, and then you can build your optimized template a little bit later on. So you see, those are the elements that we have to provide here to the system. The code, how to do our visualization, what is our input idea, what we like to explore, and how the report should look like. So this is a real closed system if you want. There's just a little bit of wiggle room for new parameters or for some new sub functions that are in your program where GPT-4 says, okay, I can code a little code sequence here and insert it here at the right place. But be careful. I can tell you from my experiment, the more comments you write in your Python file, in your program file, where you say, and now I do this, and now I calculate the following 3 parameters, and this is the name of the first parameter, and the more, quotation mark, stupid additional explanatory information you provide in the comment of your Python file, I found in my single particular mini world, the easier it is for the system to do the correct adaptation of the code to really do and execute here the experiments that it defined. Now, you can have here a look at the different templates here, and they tell you here for the grokking template, they use the code from these 2 open source GitHub repos. So if you are not sure where there's a code available, just go in GitHub, look here for the code, find 1, 2, 3 repos, look for the code that you like with the parameter and the output and whatever you are looking for, and just build here this template, and here you have a working example of this. Isn't this beautiful? So what else is there? Yeah, just wanted to show you here the ideas that were generated. As I told you here, bachelor's grokking here was the first one. If you do it, you have this and this novelty and this feasibility and this interestingness, great. But then you go on, and like as showed you in the paper, here you have more ideas, and you see novelty 4, novelty 7, novelty 8, and they are beautiful ideas. And you know what? I do this now if I do not want AI scientists to do this automated workflow for me, but even if I want to generate new ideas that I can present to you in a new video, I'm now tempted to use this workflow to generate new idea, to have a benchmark tested against the latest 10,000 publication in my domain, physics or whatever you have, and then to see what the system would recommend here as an interesting topic. And you know what? The most interesting topic are not if Microsoft has a new model, a new AI model, or Google released a new, 3.3 update. But the most interesting topic are those topics that have an impact on the human life, that are generating value in the business processing, or in medicine, or in finance, or in economic, or in wherever you go. They apply it now even for how to construct buildings, how to plan here the optimal supply chain. And this is amazing because AI becomes now a part of a process and not the dominant factor that is only with a spotlight on the AI model. So forget the model itself. We need good models, yeah, but we need to combine them, integrate them in an AI ecosystem where there are real value functions to be defined and how the system, multi-agent system work together to generate a real economic value. Okay, you find here all the files that you're looking for and all the images that were created. Have a look there. Play yourself whatever you are looking for. They have a lot of synthetic papers, example papers here. Scale denoising, the grokking, as I showed you, other denoiser than diffusion processes. It is interesting that they go for diffusion and grokking as the topic that interests them the most. So you see, just days ago this was established, but I played only 2-3 days ago. I started to play with this around, but this is really nice. It is the old model that we have, but the combination and how we combine those agents and how we use the more and more powerful augmentation, let's say, of the latest GPT-4 Omni 0808. This is now really getting interesting if you use 3.5 Sonnet here for code optimization. But you know, it's just a little bit of code wibbling around. You have to give it clear conditions, clear guide rails where it is allowed to go. Because if you read the paper, there was also a time where the code override here its internal timeout, and the code wanted to run more or less forever, generating quite a lot of monetary problems for the owner. So be careful. The author of the paper also tell you, do it in a sandbox. Watch out where this system connects to, because the code overrides itself and it creates here, if you want, unforeseen code sequences that you have to be able to stop it immediately if it becomes too expensive. Otherwise, you run into real problems. You could run into real problems. So careful when doing those experiments. Have it in some contained environment where you can stop the process immediately and watch the cost, because this system is auto-connecting to a lot of different resources to put your guide rails in place before you do the first experiment and enjoy this new beautiful idea of a real end-to-end scientist doing now here, given the complete code by me, by you and your GitHub repo, that it is able now to have new ideas, new possibilities to integrate new code sequences and run experiments over the night. This is really interesting, and it writes a research paper for you. And maybe you have a look at the research paper. Try to find out if you would detect that this is AI written. As I told you, I run some experiments also on open platforms, and the LLMs could not detect that it was an AI written paper. And I got a lot of response telling, hey, this looks like a really interesting paper by the AI system. So this is gonna be an interesting future. I hope to see you in my next video.